Welcome back, Chapter 8, Arrays, Part 2, using an array initializer. So sometimes when we declare arrays, we already know the data that's going to be in them. And when we do that, we can initialize the arrays right at the start, right when we declare them. We can also initialize them, or we can also put the data in. Okay. Um, this time we don't have to tell the program how many data elements there will be because, as you will see in a second, we declare the data right there, and however many pieces of data that we declare, that's how many that's how large the array will be. So this example is going to show 10 values. So this highlighted line in yellow is the line we're interested in. Int, square bracket, the name of the array. It's named array, how creative. Equals, curly brackets, and then we have the actual data, 32, comma 27, comma 64, comma 18, and so on and so forth. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 integers separated by commas that goes into the array. So it will be sized 10. Again, this is the 0th, 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, and 37 is the 9th value. It's not the 10th value. 0th through 9th. But the size is still 10, the length is 10. So then we say we write a little header, index, comma value. Then we write, okay, we use WriteLine. I may have skipped over this a little too quickly in the previous video. We write two things. The 0th thing after the double quotes, that would be counter, and we give it 5 positions wide, and then the 1th thing after the counter, we give it 8 positions. Okay, and one of the reasons for that is because to line it up with the data above. So we'll see on the next page, we go from counter equals 0 to 9, 9, which is the last thing less than 10, when counter is less than 10. So we'll do 9, we won't do 10, increment it, we print the counter 1 through, or 0 through 9, and the individual element, which we 32, 27, and so forth. So see what the output is. There's the output, 0 through 9, that's the index, and 32 through 37, that is the data in the array. Here's another example. We'll look at this example in a second. We made a constant, okay? Int array length equals 10, okay? This is a constant, const. It means it's not going to change. It's like a variable, but it's not going to change. We declare it in all capitals, okay? And this is just so that we don't have just this random 10 floating around, which is like, why did we put 10 in here? We're like, oh yeah, the array length. What if I ever want to change the array length? So this is just for us to be able to understand our code better later on. It doesn't make it any better or worse, it makes it a little more understandable. We declare the array to be 10 integers. It's named array, new, int. This is just like putting the number 10 in there. And then we go from counter equals 0 to 9. Okay, because 9 is the last one that's less than 10. Array bracket 0 equals 2 plus 2 times 0. Well, 2 times 0 is 0, so this is just going to be 2. We increment it, do it again. Array counter 1 is 2 plus 2 times 1, which is 2 plus 2, which is 4. So it's going to print 2, 4, 6, and so on and so forth. Let's look at the output. And there you have it. 2, 4, 6, 8, 10, all the way up to 20. Okay, once if we use this const in our program, we can't change it. It'll be a compile error. All right. Also, if we say a const and don't give it a value right away, that's also going to be an error. Okay, here's something about constants. You can pause the video and read it if you like, or view the slides at another time and read it. Okay, it just makes it more readable. And it gives us a way to make sure we understand what numbers mean inside of our program, that numbers aren't just floating around. We can add up elements in the array. Here's an example. We declare an array, int square bracket array equals, and this is the pre-declaration, so we don't have to say how many it is. It just however many we get, how many pieces of data we give it, that's how large it is. We declare a variable called total and start it off at 0, and every time through the loop, total plus equals. So in other words, total equals what the total was before plus the next element in the array. So if we add, if we're going to get the total of the array elements is, and it's going to be whatever all that stuff adds up to. It looks like it's 849. I trust it. So this is a bar chart array maker, and I don't really like this example, so we're not going to dwell on it very long. We'll do a better example later on. Basically, this is going through some grades, dividing them by 10 and truncating them to figure out the percentage, like 70 to 79, 80 to 89, and so on and so forth. And then we're counting for each individual percentage how many grades there are in that percentage set. Again, this is available as a PowerPoint, and if you really want to delve into it, you can. It does some confusing math, some not confusing, but some math that's a little more complicated that kind of overwhelms when we're just trying to work on arrays. So I'm going to skip this, but in the end, what it's done is it's figured out how that there are one person grade 60 to 69, two people grade 70 to 79, and so on and so forth. Here's a more interesting example. We're going to roll a die and use the array to count how many times we get each number on the die. We've declared an array of 7, okay? But there's only 6 sides on a die, okay? This is some tricky programming that says the die is going to be 1 through 6, so we're going to skip the 0th element. We're never going to put anything in it. 7 will give us 0 through 6. We're skipping 0. We're just going to use 1 through 6. We're going to roll a die, okay, 6,000 times. We're going to use this random numbers equals new random. This gives us a set of random numbers. Random numbers.next will give us the next one that's bigger than 1 and less than 7. We write our header. Okay, we're going to do this 6,000 times. Okay, and we're going to increment the element of the array that is either 1, 2, 3, 4, 5, or 6. Okay, so each time we go through here, if we get a 1, we increment frequency square bracket 1. If we get a 3, we increment frequency square bracket 3. So again, this is it's using some new stuff, this random stuff that we haven't used before. It's putting a calculation or a function call inside a method call inside of the square brackets to figure out which element, which is our index of our element. But in the end, we will have how many times each number 1 through 6 showed up on the die. And there it is. And it's fairly fair distribution from 950 to 1030. I could believe that would happen. Here's another use of arrays, summarizing data collected in a survey. I'm going to pause here. It's only been 11 minutes, but I don't want to run out of my 15-minute limit. So we'll come back to this in the next video. Thank you.